The primary function of all air conditioning system is to provide thermal comfort for building occupants. Utilize inverter technology to control the compressor speed. Thermal comfort is uniform and the consistency of temperature will be there. The low unit which are used especially for hotel application 1.5 TR to 2.5 TR. So you can select your indoor machine based on your requirement. You need not to go for a higher size of the machine. All machines are having a remote control. The earlier days there was a problem that if one indoor machine gets failed, the entire system gets collapsed. So I already told you about the advantages. Energy saving is up to 40%. System doesn't operate on the torque load, so you need not to design your DG on Good evening, ladies and gentlemen. I think since afternoon we have been discussing about so many buildings, about their architecture and their features and all those things. But one thing is common, that thermal comfort is equally important for that building. So here I am going to present, like most of the people, we are all aware about the air conditioning. Air conditioning is all about the thermal comfort, having a standard refrigeration cycles, and it's a fundamental of air conditioning system is used for to absorb the heat from the indoor environment and transfer it to external environment. This is how the air conditioning system works. The high pressure, high temperature gas passes through the condenser. The vapor converted into liquid, and again the high pressure, high temperature refrigerant passes through the expansion wall, and it gets expanded and gets cooled down. And this is how we operate. We get the cooling in the evaporator side. So why we do need an air conditioning? The primary function of all air conditioning system is to provide thermal comfort for building occupants. Like we have been going through all the buildings since in the afternoon, that having a building is having a different kind of structural feasibility, but inside comfort is also equally important. So it involves maintaining temperature, humidity, and the filtration of air. So this is what we need the air conditioning of an building. Here I am going to present the latest technology of VRF system, and it is all very well known to most of the guys here. The VRF and the VRV systems are both same. The only thing is the difference is the VRV word is patented by Daikin, so that other people cannot use the Daikin the VRV word. So they started using the VRF system. So VRV and VRF system is an air conditioning system where there is one outdoor condensing unit and multiple indoor units. The term of refrigerant is to flow. Refers to ability to system to control amount of refrigerant flowing the multiple evaporator, that is indoor units, and configuration connect to the single condensing unit. So basic feature of VRV system is the zoning system, which I am going to elaborate in next slides. Zoning 2 pipes, 3 pipe system, especially cooling and heating, or cooling plus heating simultaneously can happen with 3 pipe system. The simultaneous cooling and heating is available. Package DDC controls and operate as a heat pump also. The reversible cycle is also available in the similar system, so you need not to put any other system for heating as well. So all the systems, all the machines are coming with inverter technology, having a variable speed compressor. Multiple indoor units can connect up to 50 indoor units in a single system. Connected diversity, we can go up to 130%, where you can have a 13 tons of indoor capacity, and you can use the 10 tons of outdoor units. So this is how the diversity works out. So what is inverter technology? VRV and VRF systems utilize inverter technology to control the compressor speed, allowing to adjust based on the heating and cooling demand. So whatever you set the temperature, the system works based on your set point. So the compressor speed gets varied based on your inside temperature. It always achieves the temperature what you set at what is required. It works in the range of plus minus 5 degrees centigrade. The thermal comfort is uniform, and the consistency of temperature will be there. So this is the best part of the VRF system. So this is how an inverter technology. Here you can see the set point and the cardio is similar. The system works based on your set temperature, and it try to maintain the inside temperature based on your set point within the range of plus minus 0.5 degree, which is very precise. So you will get a uniform temperature throughout the time. So these are the major component uses for VRF system, like outdoor, multiple indoor units controlled by the thermostats and the central controller system. The air or water could be the source of heat ejection module. So we have a variety of the indoor units, right from high wall split to floor mounted to 4-way cassettes, 2-way cassettes, and ducted units. You can select based on your aesthetic requirement. The capacity it's having a wide range of capacities, right from say 4-way cassettes. It's available right from 1 TR to 3 TR and 0.75 to 2.45 TR. One-way cassettes you can select right from 5 TR to 1.5. Nowadays coming to up to 3 tons also. So capacity has been increased. In medium static ducted, you can select machine from 5 TR to 4.5 TR. The low unit, which are used especially for hotel application, 1.5 TR to 2.5 TR, 2 TR only. And also the one ducted, vertical ducted is also available nowadays for industrial application. So we have a wide range of indoor units and having a flexibility to use. You can select your indoor machine based on your requirement. If your load is say 0.6 tons, so we have got a unit of 0.63 tons also. So you can select your indoor machine based on your requirement. You need not to go for a higher size of the machine, unlike a conventional splits happens to be. So in all the machines, the variety of indoor capacity is very much available. You can select based on your requirement. Wall mounted units are available 0.5 to 2.5 TR, the ceiling suspended 1.5 to 3, floor standing is 0.5 to 2 TR. So we have a wide range of VRF system, in outdoor we are having a 4 HP machine to 12 HP as 8 HP machine, which is available in the single phase machine, where you can simply use in the particularly for flat area where you are having a very limited requirement of machines, 1 or 2 or 3 splits can be used with a small outdoor machine having a capacity of 4 HP, which is equivalent to 2.5 tons only. For a top discharge machine, it's available from 8 HP to 34 HP. If I convert into tons capacity of TR, it's available from 6 TR to 28 TR. So all modules are available. The variety of outdoor units are available. You can select what is genuinely needed. You need not to go to select the higher module of the machine. It has got a design flexibility. You can connect two machine with a single outdoor machine, or multiple machine can be connected. This is a typical arrangement for a VRF network, having one outdoor unit which is kept on the terrace or the balcony, and you can have a multiple units inside the conditioned area connected through a copper pipes. So this is a typical arrangement for 2-pipe systems, where you can save your elevation, you can get the major benefit of noise level as well as the elevation and the power consumption. So these are especially the similar arrangement. You can use the same machine for cooling. You can use for heating also, but if you want to use for cooling and heating simultaneously, so you have to go for a 3-pipe system, which is nowadays available. So this is an electromechanically controlled system. So every machine is communicating directly to the outdoor machines through the communication cable. So when you start your air conditioning system, you set your temperature. It gives the signals to the compressor. The compressor speed gets varied. So it meet out your requirement of the temperatures. So all machines are very much connected. We can connect with the BMS system, widely used for a good hotel applications where the entire building is managed by the building management system. So this is the typical arrangement for the electromechanically controlled module, where you are having a refrigerant piping. All machines are having a remote control. All machines are connected through the control cable, which the green line is running, and it is connected with the central controller, and it is giving a signal to the outdoor machine only. So it has got a flexibility of installations. It requires less outdoor space because we are having a outdoor capacity right from 4 HP to 32 HP. So you need not to go for a multiple spaces for outdoor machines, and you can select one or two machines based on your requirement, and you can put down the machine so that your floor space is less. So it's very energy efficient system nowadays. It's the power consumption, if you compare with the conventional split, it consumes less, almost 30 to 40% power saving in the VRF system, and it gives a exponential efficiency on part load conditions. So it's a in part load condition, like your outdoor is bigger and you're using a lesser capacity of machine, so your compressor speed gets reduced. So your condenser area, since your condenser is bigger, say 30 HP machine you selected and you are using only 60 R, so you have got a capacity of 24 tons. So your condenser area is more, so your heat transfer is fast, you will get a better cooling, you will get a lesser power consumption. So that is the biggest advantage of this system. So system has got a reliability also, because earlier days there was a problem that if one indoor machine gets failed, the entire system gets collapsed. But nowadays the technology has changed. If one machine gets failed, it gets isolated and the rest of the machine will continue to operate. So that's the biggest advantage which is available nowadays. So we have got an indoor flexibility. I told you earlier also, the capacity is available, the variable operation is available, all modes are available. It has got a very unique feature of piping length. Basically, most of the time generally happens to be like my machine is we are having a high-rise buildings where the outdoor location is the only possibility to go on terrace. We can travel our vertical piping up to 120 meters. That is the biggest, and it has and there is no deviation. There is no deviation practically happens to be in the system. Otherwise, generally in split air condition, after 40 feet or 15 meter piping, the machine capacity get reduced. So in VRF system, it's not. It's been taken care of, so that's not an issue. If you are living in a ground floor and you would like to keep your machine on 5th or 6th, 7th floor, that doesn't make much of the sense. So I already told you about the advantages. Energy saving is up to 40%. Higher COP is available. It has got a space saving because of the modular design. Noise level is very less. Indoor, even in outdoor also. So if you are having an outdoor machine just near to your bedroom area, so need not to worry about the noise level. You can simply operate and you can keep the machine near to your bed area as well. It has got a precision temperature, which generally doesn't happen with the other system. So when we now talk about this precision of temperature of 0.5 degree, that means if you are set at the temperature is 22, so your the system will work on 22.5 and that is on upper side, and 21.5 that is a lesser side. So you won't get any feeling like generally happens to be in midnight, maybe 1 o'clock or 2 o'clock in the midnight, that suddenly you will feel a chilling effect is coming up, which generally doesn't happen with this system because the consistency of temperature is there in the VRF system. So simultaneous heating and cooling option is available with 3-pipe system. Even with 2-pipe system, the city like Udaipur, which is having an extreme condition of summer, extreme condition of winter, so you need not to go for a separate system for cooling or heating. The same system can be operated for cooling as well as heating. So that is the biggest advantage, and there is no extra cost of it too. So like DG size can be reduced because I told you that system is having a variable speed compressor, so system doesn't operate on the torque load. So you need not to design your DG on torque load condition. You can simply design your DG on the actual operating load. So the DG sizes get reduced by 30 to 40%. Higher life of VRF system, I can see usually company claims that the system life is 15 to 18 years. But to be honest with you, when I came across with this system in year 2000, it's almost 24 years nowadays, the system is still working. So that I can tell you the system life is more than 20 years nowadays. So no or less duration for a longer duration of operation, because system is having a latest technology of compressor which doesn't have any mechanical duration. So system works based on your demand. So there is no mechanical contact. So there is no losses in the compressors. That is the biggest advantage. So application or users, the VRF system could be good option for a building having a multi-zone with variable load pattern. Since it's a variable system, so wherever the load is variable, you can go for a variable system. Where the load is fixed, you should go for a fixed kind of a system. Avoid users of VRF system. This is a very important slide, because building is having, there is no load patterns. Like if I talk about this hall, so there is no load because everything is working and it's working on a full load. So there is no diversities available. So whatever I'm going to design, it has to be on 100% capacity should be designed. If I design for a hotel or a office building where I'm having a 3-4 cabins, one workstation, big workstation, and a conference area where the diversity is available, where there the system will definitely perform very well. But especially load, the diversity is not there, don't go for VRF system. The diversity is there, variable load is there, go for a variable system. So this is the conclusion. VRF system is most promising energy efficient system having the excellence return of investment. Due to variable system technology, it gives a better human comfort at low operating costs, higher COP, lower size and DG, low demand, flexible fixed charges. This is important things. Generally, if we are having a flat, having a 4 split units where the demand load would be higher, if we use this system, we can reduce the demand load, that is the fixed charges going to the electricity board, we can reduce to 30 to 40%. This is the having a higher reliability of the system, already explained, higher life of the system. So thank you very much for your patience. Thank you.